All right, so what we're going to do now is look at the derivatives of the two periodic functions that we actually do play with in this course. Now, as you know, trigonometry is not a prerequisite for this class. And while I certainly encourage you to take as much trig as you can, because it's just an absolutely beautiful and useful subject area, what we need to be familiar with really is, in order to take the derivatives of our two common periodic functions, sine and cosine, is play with their graphs. So what we're going to do is, this is part of the graph of our sine function. Remember, the domain is all real numbers, so it goes on infinitely in both directions. But what we're going to do here is say, okay, this is the graph of my function. Let's graph the derivative, because this is something that we've done before. Okay? So, when you have a function and you want to graph the derivative, you may or may not recall, I'm going to do a miniature version here. All right, there's my mini graph for my derivative of this. Whenever we have a function and we want to graph the derivative, what we do is we first go to where our derivative is equal to 0. Okay? Our derivative here is equal to 0, where it changes from decreasing to increasing, increasing to decreasing. Specifically here at negative pi over 2, here at pi over 2, and here at 3 pi over 2. Now again, these graphs go on infinitely in either direction. We're just looking at a snapshot. Okay? So remember, where your function is decreasing, your derivative is negative. Okay? Derivative negative means you're below your x-axis. Now notice, from negative pi over 2 to pi over 2, my function is increasing, so my derivative is positive. It starts at 0, gets a bit bigger, and then it goes back to 0. Starts at 0, gets a bit bigger, goes back to 0. And between these two places where my derivative is 0, pi over 2 and 3 pi over 2, notice my function is decreasing, so my derivative is negative. It starts at 0, it gets to be negative, and then it heads back to 0. Starts to be negative, heads back to 0, and then notice here my function is increasing, so my derivative is positive, and we go on. Well, look at this graph. Does it look like anything else you see here? Because this graph is the derivative of our sine function, and isn't that precisely what we have over here? So cool. So, one thing that we have is, when you have your sine function, the derivative of the sine is the cosine. Okay? All right. Now, we're going to do the same thing here with our cosine function. We're going to do a little mini version of what the derivative of the cosine is. Because yes, as you would hope, there's a nice, cute little relationship going this way as well. All right. So here's my cosine function. First thing I do is identify where my derivative is 0. That's where it's changing from increasing to decreasing, or decreasing to increasing. So I see my derivative is 0 at negative pi, at 0, at pi, and again at 2 pi. All right, so now let's check out what's going on in between here. Okay? Between negative pi and 0, my function is increasing, so my derivative is positive. Again, it starts at 0, gets positive, then it goes back to 0. Starts at 0, gets positive, and then it goes back to 0. Okay? Between 0 and pi, my function is decreasing. So it starts at 0, my derivative is negative, and then it goes back to 0. Starts at 0, my derivative is negative, goes back to 0. And then we can do a similar thing here between pi and 2 pi. My function's increasing, starts at 0, gets positive, goes back to 0. All right, so just so we don't look at any confusing things here, what I want you to do is compare what the derivative of the cosine is to our sine function. Notice the zeros are in the same places, but isn't the derivative a reflection, right? Where this is negative, that's positive. Where this is positive, that's negative. So when you reflect about your x-axis, recall what you do is you have a negative in front of your function. So the derivative of the cosine is negative sine. Now, again, this is really, really rich, interesting stuff, but when it comes down to it, for the purposes of this class, as sad as I am to say it, what it comes down to is you've got to know that the derivative of the sine is the cosine, and the derivative of cosine is negative sine. Okay? Don't stress. So, what I would like to do now is just play with some examples here. Okay? Just kind of putting everything together. So, suppose I have the sine of x cubed. Here's our chain rule. Well, let's check it out. Okay? Right? It's the composition of two functions here. So, using our chain rule, it says take the derivative of the outer, leaving the inner alone. The derivative of sine is cosine, times the derivative of what's inside. Okay, what if I have y equals x times the cosine of x? How would I take the derivative of this? Well, it's important that you recognize that this is the product of two functions. So, you use your product rule. It's the first times the derivative of the second plus the second times the derivative of the first. So it's negative x sine x plus the cosine of x. All right. What if I want to take the derivative of, how about 2x times the sine of 3x? There's another product rule going on here. So let's take the derivative. It's the first times the derivative of the second. Cool, we get to use our chain rule in here. Take the derivative of the outer, leaving the inner alone, times the derivative of what's inside, plus the second times the derivative of the first, which is just 2. So I'm just going to clean this up a little bit. 3 times 2x is 6x times the cosine of 3x plus 2 times the sine of 3x. All right, what if I have something like this? Suppose I have y equals e to the x squared plus x over the sine of, say, 7x. Okay, how would we take our derivative here? Well, quotient rule. Got the quotient of two functions, so it's the denominator times the derivative of the numerator, term by term. What's the derivative of e raised to a power? It's e raised to the power times the derivative of the power, plus 1. Okay, so we've done the denominator times the derivative of the numerator. Now we do minus the numerator times the derivative of the denominator, and another cute little chain rule. What's the derivative of the sine of 7x? It's cosine 7x times 7. And that whole thing is over my denominator squared. All right. So, one more, just because we're having such a ball here. What if I want to do this? Suppose I have, and this is just going to look yuck, but it's okay. What if I have y is, who cares? Oh, let's do this. The natural log of 3 to the x plus the cosine of x squared minus, I assure you these things don't happen, e to the x sine x. Only giving one that looks like this just because it's crazy nasty looking, okay? And we get to use a bunch of different rules in here. Well, let's take the derivative. We got chain rule, we got our product rule, we got all sorts of fun things going on. Notice my outer function is the natural log. So I know that when I take the derivative of my natural log of a function, I put my function in the denominator, and now what I need to do is take the derivative of this and put it up in my numerator. Okay, let's take the derivative of it. First term, 3 to the x. That's 3 to the x log 3. Celebrate that one, okay? Next, cosine of x squared. Well, we got to use our chain rule here. What's the derivative of the cosine of x squared? Well, again, you take the derivative of the outer, leaving the inner alone. So minus the sine of x squared times the derivative of what's inside, which is 2x. Okay? Last term. Aha, I got the product of two functions, so it's minus the first times the derivative of the second plus the second times the derivative of the first. And yes, we could clean up our numerator slightly, but it's not like it's going to look much prettier. I mean, what do you have? You have 3 to the x log 3 minus 2x times the sine of x squared minus e to the x cosine x minus e to the x sine x. And again, I'm just not convinced this is any prettier. We just have fewer parentheses. All right, so I encourage you before you move on to the next chapter to get as much practice as you can with these problems. At the end of sections, if you look in the ebook, you will see that there are review problems where all the derivatives are put together, and that allows you not only to practice taking derivatives, but more so knowing when to use each rule, because that's really what tends to get students when they're first learning this material. Thanks.